Yeah, and you bet, not really.
So this section is all about, okay, ladies and gentlemen, this section is all about areas of triangles. And so, remember, area of a triangle is 1/2 base times height. What's true about the base and the height? They are what to each other? They're perpendicular to each other. That's if you have a base and then a perpendicular height, don't make it harder than it has to be. You have what you need to find the area. Okay, no trig required in that case. Now sometimes we're not given the base and the height. Sometimes we don't even have a right triangle, but we have ways to help us with these situations. Okay. So if we're given two sides and the included angle, so of course it's hard to draw these on here. So here we go. Or meters. No. Yes. Look at that picture. Yeah, good. Remember on that chart on page, I think it was 361? Yeah, 361, where it had H is equal to B sine alpha. Do I have a B and do I have an alpha? Remember, this is our beta, this is our A, this is our gamma, that's our C. So, can I actually figure out what the height of this triangle is? Yes. And do I have the base of that said triangle? Yes. So, what they're saying is, instead of height, which in our case, what's our base? What letter is our base in this case?
Wait, wide?
C.
Is wide?
Yeah.
Is B stand for the length of B or base?
This B is the base. That's why I was about to change it.
No, the one in the H equals B side.
This is side B.
Okay.
They give you this right here. If you're given a side angle side case, you can use this following formula to help you. Which is basically, you take your two sides. This is the shortcut, and here's why the shortcut works. It's because of this right here. Because you use the other side and the sine of the angle to give you your height. So what they're saying is, if you take your two sides and multiply them together and divide by 2, and multiply by the sine of the angle, it's the same thing. So all they did was a simple substitution with the height that they gave you. Does that make sense? So when you have a side angle side, which is what we have, our area is simply you take your sides that you have, divide it by 2, multiply by the sine of the angle. Now this only works for side angle side. What's that, 20? And I do not know the sine of 35. Oh, for the love. What'd you get for the area? 1.47?
Yeah.
Okay. And that only works for side angle side because of that height formula that we learned in section 6.1. Is that okay? Stay up here. In our case, they didn't give us side A, they gave us side C. So ours would have been C times B over 2, sine of alpha. It doesn't matter which two sides. If they give you two sides and the angle between it, you use that. Okay? Yes? Okay. Heron's formula is pretty cool, and this is used for if you have the three sides of a triangle, side, side, side. And sometimes we'll use the law of sines or law of cosines to get us to side, side, side. So what they're saying is if you have the three sides, first thing you got to do is they call it the semi-perimeter. And what you do is you take the three sides, add them up, and divide it by 2. Now you're not finding the average. It's not divided by 3, which is what we all want to do. It's divide by 2. This guy named Heron figured it out. I'm going to believe it. Okay. Everybody else in the world does too, so just, here we go. And then, so once you find the semi-perimeter, here's how you find the area of a triangle. Now, we're not finding height. We're not finding any of that blah. This guy was brilliant, right? We're like, oh yeah, we know Heron, okay. So what you do is you take the square root of the semi-perimeter times the semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C. And they take 2 pages to prove Heron's formula. Feel free to read along with that later if you on your own leisure time if you'd like. I'm going to believe this man, and we're going to use it.
Why?
Yeah.
What exactly is semi-perimeter?
It's the 3 sides added together divided by 2. Half a perimeter.
Oh.
Perfect. Let's do an example. Find the area of the triangle with those 3 sides. Okay, so the first thing I would probably do is draw my triangle. Oh, good. What'd they give me?
3 sides.
3 sides. So we're going to use Heron's formula. So the first thing we need to do is find the semi-perimeter. So 8 plus 6 plus 12 all over 2. 26 over 2 is 13. Okay? And then let's do it. So we go 13 and then 13 minus 12. 13 minus 8. 13 minus 6. So that's 1, that's 5, that's 7. Centimeters squared. Okay. Example 3. So 9 degrees, 9.4, 7.2. All right, not quite there. I don't have a side angle side, and I don't have the 3 sides. So let's just start finding stuff we can find. What can we find? I can't find it yet. I know I drew it like a right triangle, but it's not.
9 and 39 over 9.
Equals.
Beta over 7.2.
Good. Bless you. Let's solve for beta. So times by 7.2. And you get a decimal, and then what do you got to do? Inverse sine.
Wait, I thought just find the area.
We can't yet. We don't have enough information.
If A, B.
We don't have side angle side, and we don't have all 3 sides.
Oh.
We can't do it. Okay, now that we have beta, what are we going to find? Gamma. Now we have side, angle, side.
So AB divided by 2.
Uh-huh. So now that we have gamma, we have side, angle, side. So now we can use take the two sides, multiply, divide by 2. And then tack the side of the angle. We don't
Sine
have
of
to
which
do
angle?
the angle that's in there. The angle that you're using for the side, angle, side.
Oh, right.
So 9.4, oopsies, 4, 7.2 over 2 times the sine of, what did we just come up with? Now, what would happen if you didn't see that and you kept going? Would that be a travesty to the world? No, it would not be a travesty to the world. This means it's a little more work, but that's okay. There it is. That's it. So basically, if you don't have what you need to have, use lots of sines and cosines until you get what you want to have, and then find the area. Is that okay? Let's play one of our quick